This is a walkthrough of the first problem on the online homework for section 1.3 and 1.4. This is very similar to the problem that we had in the lecture slide, both for 1.3 and the very first example in 1.5. But I thought it might help to have a video walking through the algebra so that as these online problems vary a little bit, you'll have an example to go back to. So we're really trying to simplify this difference quotient, which is this thing. And remember, this is really this. This is the change in x's and the change in y's. So this is literally the slope between it's a slope between 2 points. One is xf of x, and remember that's the notation. This is the x-coordinate on the curve, and all this means is that it's the y-coordinate on the curve. So all it means is this is an xy pair on the actual function's graph, the function f of x's graph. And then we have another point that's nearby. So if we add a little bit to the x-coordinate here, one x-coordinate is called x, the other one's called x plus h, then those 2 points can be made close together by choosing h to be small. And you can see that over here in this table, that's what they're doing. So the x is generally fixed, and the h is being made to be smaller and smaller and smaller, which is this h that represents the distance between the 2 points that we have here. But in each case, the y-coordinate is just given as f of whatever the x-coordinate is. So if the x-coordinate is x plus h, the y-coordinate is f of x plus h. And so when we do our rise over run slope, that's the difference in the two y-coordinates. It's that minus that, divided by the difference in the x-coordinates, that minus that. And because the denominator always simplifies to h, this is the starting point that the book will use for difference quotients. So that's the first thing. So this really is just the slope between 2 points on the curve. The second thing is the algebra. Now, my recommendation for the algebra is the only difficult part in this whole thing, the only hard part is this f of x plus h thing. And so if you're not comfortable with the algebra, don't try to do that in line. In other words, don't just make a big fraction graph and try to do it all in your head. Instead, before you even go down to that step, just take a second to write out and expand and simplify f of x plus h. So if f of x is x squared, then f of x plus h means 5 times x plus h squared. So in other words, all I've done is I've taken x plus, oops, not what I meant to do. All I've done is taken the x plus h term and substituted for the x. And so now I'm going to expand this. So x plus h times x plus h with FOIL is x squared plus 2xh plus h squared. And then I have this 5 that's sitting there waiting to be distributed. So I'll have 5x squared plus 10xh plus 5h squared. So that is just what the f of x plus h part is. So now I'm going to take this down here where I have more room. If I have f of x plus h minus f of x over h, that's going to be, well, the f of x plus h part is this guy. So let me write that down. And I'll put it in parentheses just so I can keep track of what I've already done. So I'm just copying down this in place of f of x plus h. Now I have this minus 5x, sorry, minus f of x, and I'm running out of room. That's not going to help. All right, minus, I'm just going to have to, I'm sorry about that. F of x is just 5x squared. So that means I don't have to do anything to that, just 5x squared. And then that's all over, it's supposed to be a fraction bar, all over h. But notice this 5x squared and this minus 5x squared are going to cancel out. And all I have left is 10xh plus 5h squared over h. And so we write that 10xh plus 5h squared over h. So if everything has happened correctly, there will be an h that I can factor out of the top. And that is in fact what happens. So there's an h term in both of these, and so I can factor that h out, and what I'm left with is 10x, see the 10x times the h would be that, and 5h times h would be 5h squared. And then the denominator I still have the h. So this to this is just factoring out, but the reason I want to factor out is because now this cancels, and so my simplified expression is just 10x plus 5h. So what would go in this box here is 10x plus 5h. And if I have that, then it makes it really easy to fill these values in over here. I don't have to use a simplified version. I could put all of these things into this in the first place and just get the numbers. But there's a good reason for doing that simplification. So for example, if I'm using x equals 3, then this becomes 30. And, well, let me do this one. I'll do the one that's closest to 0. So if x is 3, then 10x is 30. And if h is 0.01, then 5h is 0.05. So the last row here will be 30.05. And so it's pretty clear that as these h's are getting closer to 0, as you go down the column here, when this h gets close to 0, gets very near 0, the difference quotient, the slope, is very close to 30. And so that's going to be our derivative. The derivative of 5x squared when x is equal to 3 is going to be 30, because it's getting close to that. And we can see that our derivative formula, as we go into 1.5, we can see that as this expression, if you think about the h going to 0, when h is 0.01 or 0.001 or whatever, this 5h part is very, very small, and the 10x is all that's really left. So the derivative of 5x squared is really 10x, and that's what we were talking about in section 1.5. The derivative of 5x squared is 10x, and I can see it from this calculation. But the actual difference quotient calculation has this extra stuff with h in it that if you want to get the exact value of the difference quotient, you'll need the exact algebra formula for the difference quotient.